and this one is dedicated to technology improvement or product innovation for digital transition. Before we start the workshop, I would like to share some housekeeping rules. Uh, we will record the meeting, and we would like to upload the meeting, the recording, to our website, which we open on in April, on the 1st of April. So for those who didn't register, didn't have a chance to join us today, it will be a great possibility to listen and to see what was going on today. The other thing is, please keep your cameras and microphones off during the presentations. Only the presenters should be visible. Uh, these are the in case of any questions, please raise your hand or write your question in the chat. I will try to I will try either to answer or to direct the question to the relevant speaker. This is all about the general rules. We can start the workshop. The agenda today, it's quite packed. We have only 1 hour. I will shortly introduce the project. Then my colleague Azucena will present the innovation grant, which I think is the most interesting part of the project for the SMEs. And then we start with our presentations. Today, we will talk about, as I mentioned, about digitalization. And we all know that digitalization is essential for businesses and organizations to um, remain competitive on the market, and um, to try to be on the track with the fast moving world. And we know that digitalization enables companies to innovate, to save cost, to improve their services. First of all, to operate more efficiently. And this will be the subject which my three guests will talk about today. At the end, hopefully, usually we have 15 minutes for Q&As. If there will be no time, please leave your questions, and we will try to answer them after the workshop. Um, After this, I will start with the presentation of the project. Our project, Ingenious, it's single market program called Euroclusters, and it's a very ambitious project, very demanding. And actually, our ambition is to help SMEs in develop and adopt technologies to speed up with the green and digital transformation. The project lasts for 3 years. Consortium consists of 4 clusters: Mazovia, cluster ICT, my cluster from Poland, and my three great colleagues. Baltic Net Plasma Tech, German cluster, Nano Progress, excellent cluster from Czech Republic, and our new baby, our new kid on the block is Meta Industry from Spain. What we did so far, we identified 7 challenges in energy intensive industries and similar industries, which we will discuss during our workshops. We designed 8 workshops dedicated to the challenges. The biggest part of our project is the innovation grant.
Moment ist der allgemeine Kram.
Excuse me, Alex.
Sorry?
No, Alex, could you mute yourself? Thank you. What we will launch an open call for the projects, and we will finance consortia of two or two. Oh, Azucena will talk about it. So the open call will launch in the beginning of May. Then we will distribute 1 million euros from 6 to 9 projects. We also offer internationalization grants for trips to designated markets, and also great training grants for trainings designed and needed and identified by SMEs. For us, for cluster managers, we will also have a lot of training towards on upskilling and reskilling, and also resilience and recovery, business recovery plans. As I mentioned in the beginning of April, we will have our page ready, website ready. Please join us. You will find all the necessary information, all the a guide for applicants regarding the three mentioned grants. So that's basically all about the projects. Very short description. You can read it. You will be able to read it more either on social media or on our website, or even on our cluster's website. Now I would like to give the floor to Azucena from MI4 Spanish cluster, who is responsible for innovation grants. Azucena, please.
Thank you, Eva. Good afternoon to everyone. I am Azucena Jimenez. I'm the project manager of the cluster Meta Industry 4. We are located in the north of Spain in a region called Asturias. And we are part of this consortium to develop Ingenious. So basically, as Eva was mentioned, there will be three parts in this project: innovation, the training, and internationalization. And the, let's say, most important is the innovation that will be that will be run through projects that will be funded by the innovation grants. So I would like to start with talking about these innovation grants. This want to financial support to SMEs. So beneficiaries of these projects will be SMEs. And they want to help SMEs to accelerate the implementation on the digital and green transformation. So the way this proposal has to be made is having in mind that you have to provide affordable, clean, and efficient technology solutions, or developing new business models, or through innovating with service, technology, and production lines, or open new markets. So the projects will have a duration of 12 months, 1 year, and the maximum budget per SMEs, per company, will be 60,000 euros. The SMEs will have to conform a consortia of 2 to 3 SMEs per consortia to prepare the proposals and to apply for these innovation grants. The projects will have to be in the TRL level between 6 and 9. Who can apply? As I said, just SMEs can apply. Sorry, Eva, can you go back? Can you go back with the previous slide? Okay, thank you. And the subject of the proposal of the project must be in the framework of the energy intensive industry field. So basically, the SMEs that can apply to these innovation grants must be either industrial companies in this field or providers of solution that can help give support to these industries of in the field of the energy intensive. So can you go forward? Okay. Eva? Okay, thank you. So as I said, the consortium composition must be between 2 and 3 SMEs, and one of the SMEs must be a challenge owner, and the other one must be a solution provider. If the consortia are made of 3 SMEs, then the third SMEs can be either another challenge owner or a solution provider. The key dates that you must have in mind are the following ones. The proposal submission starts the 2nd of May till 3rd of July. Then the members of the consortia, the 4 clusters, will have some time for the proposal reviewing. Have in mind that we will not have how you say, sorry, I don't find the word, but can you help me?
For what?
Okay,
Sorry,
there will be no chance for any justification or for any adjustment or
rectification in the document.
rectification of the documents.
Yeah, sorry, I couldn't find the word. So there is no chance of rectification. So you will have to be very sure that all the documents are eligible, and all the information is accurate, and everything is done when you submit the proposal. And then we will have July and August to review the proposals, and the evaluators will have the time for the assessment from the 1st of September till the end of October. The evaluators will be independent, experts, and international. Then the evaluators will give us the score of the projects, of the proposals, and we will give the budget to the project. So there will be probably from 6 to 9 projects awarded. The signature of the agreement will be the following step that the awarded projects will have to do. So from November till half of December, and then we will have some time for Christmas time and for relaxing a little bit, and the projects will start the 1st of January. So and it will be run for 1 year, as I said. So, Eva, can you? Thank you. So all this information and is coming in the web page that is now under construction, but we will be available in a probably in 2 weeks. You will find there all this information and more. And if you want, you can take my email address, that is this one, proyectos@metaindustry.com, and I will be very happy to help you with all your questions. Thank you very much.
Thank you, Azucena. As we promised, it's a very short presentation due to the time limitation, but we are here to help you and to answer all your questions. So right now we can start with our presentations, and the first guests are from INTELO, Mr. Norbert Krieger and Adam Binkiewicz. They will provide the IT solutions as a way to optimize production costs. Gentlemen, the floor is yours.
Okay, thank you. Norbert, can you start the first
Yes, definitely.
side of our presentation? Short introduction from my side. We are both here with my colleague Norbert. We are board members and owners of INTELO. We develop modern innovating solutions for SME, but not only. The combination of two backgrounds, my several years from strategy consulting, supporting international companies, mostly from the Germany area, like example Miele or VSH, and Norbert over 25 years developing IT solutions. And now maybe a short presentation of what we can provide for some companies which are interesting to optimize production costs.
Hello to everyone. My name is Norbert Krieger, and I represent INTELO company. As my colleague Adam already said, our company specializes in development and implementation of dedicated IT systems for enterprises. So we deal with custom-tailored solutions. We do not offer ready-made box software. Every single project is developed, is prepared in a very close relationship with our customers. This can lead to gain the real benefit in the form of functional areas that exactly map the requirements. In order to be able to provide different technologies, we have cooperation with Zebra, a company that provides us with modern and very sophisticated authentication and automation devices in the field of identification using barcodes or RFID technologies. So our approach is to very carefully understanding the company's requirements and the company's processes. Each company is unique. Each company has its own business processes, and all these processes interrelate with one another. So to properly understand how the company works and what are the real problems, challenges, and what are the possibilities of digital transformation, the first phase is to carefully analyze those processes. And we start each process with getting the knowledge necessary required for developing the final system. Because our approach assumes that these all processes are related together, so we try to analyze the company as a whole, trying to find those interlinks between different functional areas. So we analyze purchase or supply area, warehouse and logistics, sales, and of course, production. Then we try to support all these processes from the management point of view, of course, administration and strategic decisions. Because we do not have much time just to give you a sample of what functionality can be provided. Here we have some supply monitoring and management information that presents supply requirements that are automatically generated. It's based on the information entered into the system in the form of bill of materials. So if we have all precisely defined bill of materials, all the supply process can be supported. And we can have very current information about the progress of how each particular component or material is available at the particular point of time. So in case any problems would appear, we can react accordingly. Having everything prepared for production, we can deal with production orders. So we are able to monitor and manage all the production orders that have been entered into the system. All the process can be very easily analyzed and can be very easily observed. So in case of any problems, situations that must be resolved, the users of the system are notified. Of course, this process also allows you to monitor every single production operation. Every single production operation is defined and also is described using the input and output components that are used in the particular production operation. Because we provide the touchable screens and terminals that allow you to record all the operations they start and also when they finish. So we can very easily monitor in what point of the process we currently are at the moment. So also we can monitor all kinds of delays. If the expected time is extended, we can also take some action. And this process can be very detailed, and of course, it also depends on the particular company and its requirements, and can be properly adjusted. Because to be able to get the data to the system in the field of production processes, we need the proper software that is developed and installed on terminals, which are then installed at the workplaces. So at each significant workplace, this terminal is installed, and using our custom tailored software, we are able to report the beginning and the end of each particular production operation. And also we can provide any kind of functionality that would be useful at the particular workplace. So the workers, the operators also can be assisted with some information, data, or documentation. Sometimes we need to provide the functionality using smaller devices, especially in the area of logistics or warehouse management. We develop and deploy our own custom tailored software that can also support not only warehouse management processes, but also production processes. This is all the functionality is finally adjusted to customers' requirements. So in this field, there are actually no limits. We're completely flexible. And just to spot some benefits that our clients have, definitely faster implementation of changes in production processes, because all the processes, the production processes in particular, are in the system, then can be very easily adjusted in very short time. So all the tasks that are delegated to workers can be efficiently in very short period of time delivered. Then the flexibility. We design our software to be flexible and to allow easily modification of all the operations and all the information that is provided to our users. Then we have the revenue growth that is the result of lowering costs and also to making the process more efficient. So in the same time, we're able to produce more goods. Because we can meet our deadlines, the satisfaction growth and investment plans also appear available to the client. And it all leads to finally increase in profitability. Just a sample solution that we have implemented it in one of the major gear motors provider, that's SEW Eurodrive Corporation. The problem was that the assemblers at the assembly line made a lot of mistakes when they were assembling gear units. And well, the company wanted to assist them in their work, in the process. So we have designed and implemented and developed the system that utilized RFID tags and barcodes, and that when the tray with the tag attached came near the workplace, the reader read the code, and the proper information could be provided to the operator. So these are some sample screenshots that present this functionality, and this functionality allowed to eliminate a lot of errors, not properly assembled units, and also this solution reduced the requirement for using paper documentation, because all the documentation could be also delivered to the workplace. So this is only a sample. Of course, this is a very broad subject topic. In case you will be interested in more details, you're welcome to ask the questions and direct contact with us. Thank you very much for.
Thank you very much, gentlemen. I just got scared that I forgot to start the clock, but I think that you used your 10 minutes without any extension. So thank you very much. And from your presentation, this is what I mentioned in the beginning, that digitalization helps you to save money, to increase your profit, and just to optimize your production processes. So in case of questions or asking for a contact, we will be happy to forward the presentation and the contact details to all of the participants. Once again, thank you very much.
Thank you very much.
Our next presentation is Professor Adolf Mirowski with digital model of CHP plan, presenting digital twin. Professor Mirowski unfortunately does not speak English, speaks other languages fluently. So we would make easier for you, and we will have a simultaneous consecutive translator. Professor Mirowski, the floor is yours, and now I start the clock. Thank you.
Dzień dobry, dziękuję bardzo. Dziękuję także za nominację profesorską, chociaż profesorem jeszcze nie jestem, ale może w przyszłości, kto wie. Mój wykład będzie tłumaczyć pani Agnieszka.
So, good afternoon, everyone, and also, dear host, thank you for promoting me to the professorship. I'm not a professor yet, but perhaps in the future. And today I will be assisted by an interpreter whose name is Agnieszka.
Mam pytanie, czy prezentacja już się u państwa wyświetla?
Can you see my presentation on your screens?
Yes, yes.
Okay. Reprezentuję osobiście Instytut Certyfikacji Emisji Budynków, który jest członkiem klastra ECN, a grupa, która jest zaangażowana w ten projekt, ich loga są tutaj wymienione po lewej stronie.
I represent the Building Emissions Certification Institute, which is a member of the ECN cluster. And actually the parties involved in the consortium, you can see their logos on the screen.
Otóż w całej Europie przed ciepłownictwem sieciowym stoją bardzo ogromne wyzwania. Jednym z nich to jest udział energii odnawialnej w strukturze produkowanego ciepła.
District heating networks all over Europe are facing huge challenges. And one of these challenges is the share of heat produced from renewable energy sources.
My w Polsce na tle tego wykresu jesteśmy na razie, mamy całkiem niezłe miejsce, mieścimy się jakby w limicie na dzień obecny.
So when you look at the chart, Poland is quite well placed, so we meet the target, the current target as of today.
Ale niestety w przypadku, jest jeszcze kolejne zadanie, to jest redukcja emisji CO2 w przypadku wytwarzania energii elektrycznej i też wytwarzania ciepła. W 2050 roku powinniśmy już być krajem neutralnym pod względem emisji CO2.
But there is another challenge, and this challenge is reduction of CO2 emissions. And I mean here emissions from generating both electricity and heat. And by the year 2050, we should actually be neutral to the client. Our emissions should stand at zero.
W tym miejscu nasze miejsce nie jest zbyt chlubne, mamy dość wysoką emisję. To jest ponad 400 gramów na kilowatogodzinę ciepła dostarczanego do klienta.
And these are our current emissions, and it's not a very good standing, I must tell you. We are producing roughly 400 grams for every kilowatt hour of power produced.
I w tym naszym zespole postanowiliśmy opracować całkiem inną elektrociepłownię, tak zwaną elektrociepłownię przyszłości.
And within this team, we decided to develop a completely different plant. This will be a CHP plant of the future.
Polega ona na tym, że przy powrocie wody sieciowej pierwszym stopniem podgrzewania ciepłej wody są pompy ciepła typu powietrze-woda.
And in this system, the mains water is preheated by heat pumps, and these are air-to-water heat pumps.
W dalszym stopniu mamy kolejne pompy ciepła. To są pompy ciepła typu woda-woda.
And then water is heated again, this time by water-to-water heat pumps.
Która wykorzystuje wszelkie ciepło odpadowe, technologiczne, jakie powstaje w naszym systemie.
And they use up all the waste heat that is generated anywhere in the system.
A ono powstaje w ekonomizerze kondensującym agregatu kogeneracyjnego.
And this waste heat is, for example, generated in the condensing economizer of the power unit.
W układzie turbodoładowania.
Also in the turbocharging unit.
I w ekonomizerze kondensującym kotła szczytowego.
And also in the condensing economizer of the peak load boiler.
Trzecim stopniem podgrzewania ciepła sieciowego to jest moduł kogeneracyjny zasilany biogazem lub gazem ziemnym.
And the third stage in which water is heated is the cogeneration unit, which is powered by biogas or natural gas.
A jeżeli tego ciepła będzie brakowało w momentach szczytowych, do tego służy kocioł gazowy.
If there is insufficient heat at the peak moments, peak load times, there is also a special boiler for biogas and gas.
Kluczowym tym elementem jest dostarczany biogaz z naszej nowej budowanej biogazowni.
In this system, the key element is the supply of biogas, which comes from a newly developed biogas plant,
którą budujemy od miejsca docelowego 9 km dalej.
And this biogas plant is being developed roughly 9 kilometers away from the future CHP plant.
Oczywiście na początku opracowaliśmy model cyfrowy całej elektrociepłowni.
Initially, we developed a digital model for the entire plant.
I nakarmiliśmy ten model danymi rzeczywistymi, czyli danymi meteorologicznymi i wszystkimi parametrami technicznymi, czyli nazwijmy to parametrami termodynamicznymi, czyli jakie są temperatury, jakie jest zapotrzebowanie na moc i inne.
And we fed that digital model with all real-life data we had access to For example, we fed it with weather conditions data, technical data such as temperatures and the demand for heat.
I otrzymaliśmy bardzo dużo wyników w postaci wykresu, jak i w postaci tabelarycznej.
And we received, as a result, a lot of output data. Some of it was presented in tables and some of it was in the form of diagrams.
To pozwoliło nam opracować taką strukturę układu jak zbliżoną, tak jak się stosuje to w układach rzeczywistych. Mamy wszystkie urządzenia wyszczególnione i wszystkie parametry termodynamiczne są tutaj też są ujęte.
This helped us build a digital system, and it includes all the devices and machines that are included in the real life system, and it also presents all the technical performance data.
Na tej podstawie możemy opracować też cały zupełnie nietypowy system sterowania tym systemem, tym układem.
And based on that, we can also design a very unconventional control system for the entire plant.
Gdzie na podstawie zapotrzebowania na ciepło i danych rynkowych, na przykład ceny paliw, ceny energii elektrycznej, możemy stosować różne scenariusze zdarzeń.
And when we use data such as the demand for heat and market data, including the prices of electricity and the prices of fuel, we can model some actual projections.
I możemy przewidywać nie tylko w czasie rzeczywistym, ale także z wyprzedzeniem. Możemy planować i programować temperaturę, potrzebną moc, jak i również zapotrzebowanie na biomasę.
And we can, in real time, control the plant and program, for example, the temperatures, the outputs, and the demand for biomass. But we can also program the plant for the future demands.
Na dzień dzisiejszy rezultaty są bardzo imponujące.
At this moment, the results we have achieved are quite impressive.
Udział energii odnawialnej jest na poziomie 93-95%.
The share of energy from renewable sources stands at 93.57%.
A efektywność energetyczna systemu jest około 97%. To jest bardzo wysoka wartość.
And the energy efficiency of the entire system is roughly at 97.2%, which is very, very high performance.
Także po uruchomieniu powinniśmy się znaleźć w tym punkcie, jeśli chodzi o udział OZE i w tym punkcie, jeśli chodzi o emisję CO2.
Once the plant is launched, we should be roughly at this point in terms of CO2 emissions and in terms of share of heat from renewable resources on the previous slide.
Praktycznie w 2025 roku będziemy spełniać już wymagania z roku 2050.
This means that as early as 2025, we will be able to meet the targets designed for 2050.
Obecny stan jest na koniec lutego, tak jak tutaj mamy już wszystkie fundamenty przygotowane, a docelowo będzie system wyglądał jak na tym zdjęciu.
So in the previous slide, you were able to see the plant development site as it looked at the end of February. And this is the target state of the plant. This is how it's going to look like in the future.
Dodam, że ten system realizujemy dlatego, że wygraliśmy narodowy konkurs finansowany przez Narodowe Centrum Badań i Rozwoju.
And let me also add that we are developing this plant and this system because we won a competition, a national competition, and the project is being funded by the National Center for Research and Development.
Dziękuję bardzo. To wszystko z mojej strony. Jeżeli będą szczegółowe zapytania, podaję też swoje dane kontaktowe.
Thank you very much. It has been all in my presentation. If you have any detailed questions, I have provided my email address and my telephone number for you.
Dziękuję bardzo.
Thank you.
All right, thank you very much. Professor, I'll keep the title for you, so you have a challenge. Thank you for the presentation. It was very interesting. Since I'm the plant for future is our flagship project, so I'm quite familiar with it. Just worth to mention that CO2 emission is one of the challenges we identified in Ingenious, and we will have another workshop on this subject. So we are inviting you right now. And last but not least, it's our guest from Astor, Mr. Marek Zamojski, with the presentation on artificial intelligence solution, which optimizing industrial processes and plants. Mr. Zamojski, the floor is
Good
yours.
afternoon. Thank you. I will show my screen. Just let me know. Is it visible? Is it visible now?
Yes, yes, it
That's
is.
great. So, good afternoon, everyone. My name is Marek Zamojski. I've been working in Astor for over 15 years for now, and for last 13 years, I've been working as an IT director in Astor, and currently at Astor, I'm responsible for business line, software business line. This software business line is dealing with digital transformation of the industry. We're using the software is the software from Aviva distributor, the market leader on the world on industrial software. And Astor is a part of also a European Digital Innovation Hub, and together with my team specialized in artificial intelligence, we deal with the topic of artificial intelligence for industry. So over 5 years ago, we established a dedicated team because we saw that trend that artificial intelligence is used more often nowadays in industry. So in this team, we focus on connecting the IT world, in particular data scientists, with the world of automation, because we have to connect those two worlds to make that kind of project happen. And to do so, we use the knowledge and the knowledge of our partners, but also the already made Aviva solutions for industry. So who is Aviva and Aviva in numbers? So we have been specializing in solution for industry for over 28 years and have already helped over 2,000 clients in digital transformation using Aviva tools that have been implemented in over 20,000 companies all around the world. So today I would like to tell you about why artificial intelligence is gaining more and more popularity these days. Because during the third industrial revolution, we was focusing on making decisions quickly based on our collected data, and nowadays we've got the third industrial revolution. We have to make, in my opinion, too many decisions at once, and that's why the artificial intelligence becomes the answer for managers, for people in the industry who have to make those many decisions at once every day. So. From our experience with the use of artificial intelligence, we have noticed that the process of implementing artificial intelligence usually goes into efficiency, particular energy efficiency, and predictions, in particular predictive maintenance. This process usually goes like that we've got some device, we have to collect the data from that device, then we prepare some data analysis, and based on that we build some algorithms. And as I said before, usually it goes to efficiency and prediction. So let's start with example of implementation artificial intelligence in the wastewater treatment plant in city of Krakow. I will present the path of this sewage treatment plant to fully digital transformation and use the artificial intelligence to increase their energy efficiency. So, as I said before, and as you saw on the slide presenting the process of the implementation of AI, everything starts with the data. So, if we think about we want to increase our efficiency, we have to collect data. The analyst of energy data showed us in this example elements that we have to be focused on. So we choose the second stage pumping station in this case due the plans to modernize the blowers. So we don't want to use dedicated algorithms on the system that will be modernized, and the high failure rate on the first stage pumping station. So what were the savings from the implementation of the system? The digital transformation in terms of energy efficiency usually goes in two stages. So the first stage is the stage consists in media monitoring, and in this stage, this system allows water waste treatment plant save over 3 million Polish zlotys per year on energy savings. Only with Aveva system platform and use the knowledge of the people who works in water treatment company, and when they can see the data from energy point of view. And this is usually the first stage of energy efficiency, and that stage does not require any artificial intelligence and allows the gigantic returns of investments. And the second stage elements is the artificial intelligence. So when we collect the data, when we use that with our knowledge of people who works in the factory, we can then use artificial intelligence algorithm to make the process better or make some predictions that allows us to save some costs. So the second, as I said, path to using artificial intelligence from our experience is go to predictive analytics, because if you're dealing with some troubleshooting in industry, usually you have to look at this kind of scans, this kind of reports that shows you thousands of signals from industry, and people who is responsible for the factory try to get to know what happened during that incident on the factory, and how it usually looks like in industry. We are focused on putting some levels, some warning levels, and try to look at every signal in the single way. But this don't allow us to make any decision faster, because in predictive analytics we have to focus on that we know about the incidents before it even happened. Because if you get some warning that temperature is over some level, that usually is after you can't do anything with that. Because the warning is too late and incident probably will happen in few seconds or minutes. And in predictive analytics, we have to focus on prevention. We have to focus on get the information as soon as possible, and we can do that with the prediction how signals should look like. So the systems in AVEVA Predictive Analytics using the prediction models from artificial intelligence for every signal. So if we have thousands of signals in our factory, they look at once and look the correlations between them to get the information and looking for some anomalies on that signals. So optimizing the asset strategy can be a bit challenging. So and often when we first start to work with customers, we find that they over maintaining their assets, which comes to the high cost. And in some cases, under maintaining their assets, which is more obvious and leads to reduction in reliability and performance. We can see on this chart that an optimum risk based on maintenance strategy carefully balances risk, cost, and performance. So that plant production assets are not over-maintained nor under-maintained, but where asset maintenance is performed in the most balanced and optimized way. And we get this right where we get all outcomes that we see here on the right with increased reliability and performance, reduced downtime, reduced maintenance cost, improved labor productivity, and optimized asset strategy that defines that how maintenance is performed. So we have to find the optimum way, not too expensive, but not under-maintained. And that's the key to implement predictive maintenance. So if you want to get this process and predictive analytics on one slide, we have to focus to gather some historic data, because if we don't have any data from our factory, we don't have the source for making some improvements. And other way, then we can use, for example, AVEVA Predictive Analytics to pattern recognition and get some early warnings for our crew to don't let that event happen. Then if some events already happened, we have to build some knowledge base and look at this event on data correlation of the data that we get in our systems. Because if we look on the historical data, we can't have the right knowledge what was the reason of the event. But using artificial intelligence, we have the right answer that one of those signals, for example, this red, is responsible for that event. So going to the end, where this could be used, there is hundreds of implementations of AVEVA Predictive Analytics. For example, if FMCG, like baking company, like chemical industries, but usually also in oil and gas branch or energy sector. So that's all from me. If you've got some questions, I'm happy to answer it. Thank you.
Thank you very much, Mr. Zamoyski. Thank you. I know that we have some some guests from other partnerships, from water clusters. So it might be dealing with the wastewater and water management. So it might be quite handy for them. Plus, we have an excellent solution provider for consortia to apply for our innovation grants. Unfortunately, we do not have time for questions. Sorry for that. If you have any questions, contact your person from the cluster or contact us via our website. At the end, I would like to share the next workshops. We have an ambition to have a workshop every week, every Thursday. So we invite you for the workshop number 4, which will be on efficient and sustainable decarbonization processes, hosted by BalticNet Plasma Tech, and then followed by 4 more. So stay tuned. We will give you the details. We will send you emails, but most of all, I encourage you to follow us on our social media accounts, where we have all updates. Once again, thank you very much for your presence. Thank you for my guests. Very interesting presentations, and hopefully see you in such a big crowd next week. Once again, thank you very much all. Bye-bye.
Thank you. Bye-bye.
Bye-bye.
Thank you. Bye.
Thank you very much.
Bye-bye.